This is the diagram of some reversing polarity relays being controlled by a switch that stays closed, a latching closed switch in one position and then open in the other position, and some reed switches that when the magnet gets up to next to the switch will stop the motor from turning. So you have your power supply and your load here. We've got some fuses here. So it's going to depend on what your loads are and what size wires you're using. And what we're going to do here is that we're going to go through this switch here, or whatever you want to control. I'm just using a switch for right now. So when this closes, it'll put power to this side of the relay, the coil in the relay. So it's going to close the relay and put power through this switch here. So when the magnet is not next to it, it's closed. So that's going to put power to this relay, changing this relay to positive. This one will stay negative. The motor will turn in one direction. When the magnet gets up to the reed switch, or you can use a micro switch with a spring lever, this will open and that'll stop. Then when we change the position of this switch here, this will de-energize, and then this will be closed from here to here, putting power through this switch and energizing this relay. So this one goes back to negative, and then this will be a positive, and then that'll turn the switch the other direction. So we'll break this diagram down a little bit. This will be the negative circuit. So I've got two wires. I'm going to feed the coil side of all the relays. These are where the wires are connected. So where they cross here, they're not actually connected. When there's a dot, that means that's a wire, and that's a wire. So we're going to feed a negative to each side of the coils, and we're going to switch with positive. Then this other one here is going to feed our load. So we're going to go to that terminal there on the relays. So in this position here, these are both have negatives, which will do nothing to the motor. The motor can't turn with two negatives. So that's the negative circuit. So here's the positive circuit. We're going to use two wires again. We're going to use a wire to control the loads on the loads for the motor, and then one for the coils. So that goes through the switch, going to feed that side of the coil. And then these other ones have to go through this relay and these reed switches to feed the other side of the coils. And then this is our load here. So that's here, and then that's just jumped over to this one. And then our commons off those relays feed the motor. So that's the positive side of the circuit. So this is an example of what happens when this switch is closed. So we can see power is going through here, feeding this side of the relay, which switches the power to here, going through this switch, which now is closed, and feeds this relay here, which is going to close this relay from here to here, putting power, positive power to this side of the load or your motor. And then your negative, this one is not energized, so it stays negative. So you can kind of see how that circuit works. So if we were to put a magnet here, this would open, motor would stop turning. If we open that switch, the motor would start turning again because this would change. So the power would be going from here to this one and feeding power to this relay. And then once the magnet got next to that reed switch, it would open, and once again, motor would stop turning. Okay, so I mocked something up here that's like the diagram, and we'll see if we can wire this up and make it work. I've got the motor wires hooked up right here. So a positive and a negative here. Those go to this little motor. And then we'll do our negative wires. So we have two that are going to feed the load. Those are going to go on our middle terminals here. So right now both of these wires would be negative with nothing else happening. And then we need to have a negative on the coil side of the relay. So we're going to use this side here. There's our negatives. So now whenever one of these get a positive signal, it's going to change the state of these relays. These two wires here are going to this switch. So it's just a close or an open switch depending on which way you push the terminals. And so this one here we need to feed down here on the common. So this one from the switch goes to here. So we can change the state of this one. Okay, and then these go here and here. So now we have a positive feed. So if we change the state of this one, this will turn positive. If we change the state of this, this will turn positive here. Okay, this is our feed from here. That's going to feed from our power supply. Okay, and then we need to hook up these here. So this one here, according to the diagram, one side goes to the reed switch, which is the middle of here. And then this one's going to feed this relay here. Okay. Then this switch here is coming off this side of this relay and is going to feed the coil on this relay. So we supply power to it. If we push the button, we got the motor turning, which would move something, whatever we're trying to move. And when the magnet gets close to the switch, it stops. So that's our stop switch. And then if this switch here goes into the other position, now the motor's turning the other direction, it would move whatever we're trying to move. And when it gets lined up there, it does that. So with the reed switch, you got to be careful with how you place these, because that reed switch is going to close that switch right there. So if you're trying to line it up and you want it to move a certain direction, that's why a micro switch might work better. That's what I've used in the past to stop something from moving that I was trying to operate. And so we move the switch there, and it stops there.